Okay, finally, a couple of examples involving radical expressions. So simplify, and the instructions on the test will be write in exponential form. All right, so first example we can look at here, let's talk about 1 over the square root of 5a cubed. So now I rewrite this in exponential form. So the first thing that you need to do is you need to get rid of any radicals. So on the denominator, it's going to remain cubed, that whole expression, but inside that expression, we're going to rewrite that as 5a, so in brackets, 5a to the exponent 1/2, because it's a square root, it's a radical. Next thing we need to be able to do is multiply. So off to the side here, I'll put it in a star, 3 times 1/2, because power of powers. Calculator will do that, but hopefully there are some people in here that know that 3 times 1/2 is just 3/2. Okay, so there's an example of writing it in exponential form. I'll do one more. So let's look at, where did it go here? Sorry about that. Let's go with the 4th root of 3n to the 9th. So inside, you know that the outer bracket is a 9. Inside that 3n, we're going to get rid of the radical sign, rewrite it as an exponential. It would be to the 1/4. Now we know that 3n will have an exponent of, and again, power of powers. So it's 9 multiplied by 1/4, and that would be 9/4. Right, and just before we get to the homework, make sure there's some other ones. I've already showed you how to evaluate. The more challenging questions are when they're going to be mixed up a little bit with our exponent laws. So I'll give you 2 examples with that and then let you try this on your own. So we got a to the 1/2, b to the -1. That's going to be multiplied by b to the 3/2 divided by a squared to the 1/3. So when you're looking at this, you're thinking it's going to be impossible, it's going to be really, really hard. What you need to do is you got to remember, we're just dealing with fractions, and if you can find your fraction button on the calculator, it'll make your life that much easier, but most of the fractions are kept such that you can do it without. So first thing I'm going to do, I'm going to multiply the numerators together. I'm going to get this cleaned up right here. So there's no other a term to multiply with, so it's going to remain as a to the 1/2. Now the b terms, they're like terms, they are multiplying, which means that I need to add the exponents together. So b to the exponent, and I'll do this off to the side, okay, -1 plus 3/2. That's the same as -2/2 plus 3/2. So adding the numerators, because denominators stay the same when you're adding, would be 1/2. You can double check this. If you're going to use the calculator, which you're free to use on a test, you should give you the 1/2. In the denominator, we have a power of power situation. So these need to be multiplied together. And we end up with a to the exponent 2/3. Now I have some division going on. I have a's, the same base, so I got to deal with that. So the b is going to remain. There's no other b's to deal with. My a's, oops, I'm not even going to have a fraction in the end of this. So b to the 1/2, b to the 1/2. My a value, I have to take, and I'll do this off to the side to show you what you're going to do with your calculator, or you're going to do this by hand, 1/2 minus 2/3. Get a common denominator, which would be 6, which would mean that this had to be a 3 minus 4. So to be -1/6 would be the exponent on the a. And if you're using the calculator, that should be the answer it spits out. Communication, can't leave a negative exponent in your answer. So final answer, b to the 1/2 over a to the 1/6. All right. I'll do one more example of that caliber of difficulty. That's your upper end questions right there that I want you to try with the homework. So we are on example number 4. So pick another one off here. So let's do bracket a to the exponent 5/3, b to the exponent negative 4/3. That's the exponent 3/4 divided by n to the 5/3 multiplied by, oops, sorry, that should be a b. b to the 5/3. Bring that up a little bit. And a to the negative 1/2. Okay, so first things first, I'm going to look at the numerator. And in the numerator, I have a power of power situation. So I'm going to clean that up first. Again, if you're using a calculator, you need to multiply the exponents. So this 3/4 is going to multiply each of those exponents. So 5/3 times 3/4. You can verify this with the calculator if you need to. If you don't believe me, a to the 5/4, b to the exponent 4/3 times 3/4 actually turns out to be a negative 1 on top. The denominator, they're not the same base. I'm just going to change the order. Because order doesn't matter with multiplication, so I just switch the order up. Now I'm going to use my rules. I have the same base of a. It's division, so I'm going to have to do subtraction with the exponents. So off to the side, I have 5/4 minus negative 1/2. If you plug that into the calculator, it'll spit out an answer. This is 5/4 plus 2/4. So my a exponent will be 7/4. My b, so now I'm looking at similar base b. So I'm going to have, I'll put it down here, negative 1 minus 5/3, get a common denominator, which would be a 3. So negative 3 take away 5, so negative 8/3. So my b will have an exponent of negative 8/3. For communication purposes, the 8/3, b needs to go to the denominator. And there you go. So there are the examples that will get you through the homework. There's a lot of homework, but this is kind of this lesson would normally extend over 2 days. I would do a lesson and then you'd have a work period the following day. So the way this would work is probably the next 2 days in class you're going to be working through this. Some of them are short answers and they get progressively more challenging. So good luck, and like I said, I'll be in class to give you a hand with them. So we'll see you then.